Good afternoon. My name is Estelle. I'm from University at Albany, State University of New York. The topic I'm going to present today is preference for harmony, a link between aesthetic responses to combinations of colors and musical tones. Numerous studies have sought to understand factors that contribute to simultaneous consonance, which is the perception of some musical chords sounding more pleasant than others when heard in isolation. These factors include harmonicity, roughness, and familiarity. However, a gap exists between understanding musical experience and aesthetic experience more generally. This raises the question, do we evaluate the pleasantness of other aesthetic stimuli, such as visual art, in the same way we evaluate musical chords? A unique study by Palmer and Griscom addressed this issue and found there is a potential link between pleasantness judgments for stimuli in musical and non-musical domains. They created an individual difference variable, preference for harmony, which they defined as how much a person likes or dislikes stimuli whose parts go well together in the sense of being good gestalts. Palmer presented participants with a range of visual and auditory stimuli and asked them to rate their preference for each stimulus and how harmonious it was. The visual stimuli included color combinations, dot patterns, and the circle in the frame pictures. The auditory stimuli were Western classical piano excerpts. Preference for harmony scores were calculated as the difference between each participant's preference and harmoniousness ratings. Palmer found a strong correlation between preference for harmony scores across 4 domains, with responses to color combinations and music having the highest correlation. This means that people who prefer harmonious color combinations also prefer harmonious music. In our study 1, we first want to validate and extend Palmer and Griscom's findings using a distinct set of musical stimuli. We are especially interested in which objective musical features contribute to people's harmoniousness judgments. We also want to determine if preference for harmony only represents a preference for good gestalts, or could it also reflect a preference for more familiar stimuli. From a cognitive perspective, Palmer defined preference for harmony as a preference for good gestalts, which are stimuli that are simple, structured, and therefore easier to encode into memory. However, encoding ease does not only concern structural goodness, it can also be related to the accessibility of stimulu's mental representation. For example, a stimulus that we recently encountered is easier to process because it has an active mental representation. This processing fluency may stimulate positive emotions because it is associated with error-free processing and successful recognition. Moreover, harmonious stimuli that are easy to process due to structural goodness might also be easier to process due to their familiarity. A simple and structured stimuli might be more common in everyday life. Therefore, there is a possibility that preference for harmony may actually be a preference for familiar stimuli instead of a preference for harmonious stimuli. We limited visual stimuli to color combinations because the highest preference for harmony correlation was found between music and color in Palmer's study. We used the same 56 color pairs consisting of color combinations from the blue, green, red, and yellow hues in both light and saturated cuts. For instance, on the left, we have a color combination with a high harmoniousness rating, and on the right, a lower rated one. Instead of classical music, we used isolated musical chords. Our musical chords were 44 Western 12-tone equal-tempered triads, each with a bass note of C4. They were randomly selected from 66 possible triads within an octave. By using isolated musical chords, we were able to compute objective features of the musical stimuli, including their roughness, harmonicity, and familiarity. We investigated how these objective features were associated with harmoniousness judgments and individual differences in preference for harmony. Roughness represents the extent to which a chord's partials interfere with each other. Harmonicity represents the extent to which a chord's frequency spectrum resembles a harmonic series. It's important to differentiate between objective harmonicity and subjective harmoniousness. Harmoniousness is a perceptual attribute measured through subjective participant ratings. On the other hand, harmonicity is an objective property that can be quantified. Familiarity represents how often a chord occurs in the listener's musical culture. We estimated the objective familiarity of each triad by computing the frequency of each triad in the corpus of Western, classical, jazz, and popular music. Our findings were consistent with Palm and Griscom's findings. The left two scatter plots show average harmoniousness versus preference ratings. We found that zero-order correlations between preference and harmoniousness ratings were high for both color pairs and musical chords. The right two histograms show correlations between each participant's harmoniousness and preference ratings. We found great variability in the magnitude and direction of these correlations, which provide the basis for individual differences in preference for harmony. The correlation between preference for harmony for the color combinations and musical chords was 0.63. This also closely replicates Palm and Griscom's correlation of 0.6 between preference for harmony scores for these types of stimuli. Next, we used the three objective musical properties to predict subjective harmoniousness ratings. We found that roughness and familiarity uniquely contributed to harmoniousness, with roughness being the most robust predictor. Objective harmonicity, however, was not a significant predictor. We also regressed musical preference for harmony on our own measures of preference for harmonicity and familiarity, as well as aversion to roughness. And we found that preference for harmony was uniquely associated with aversion to roughness. Using a distinct set of musical stimuli, we also found a correlation between preference for harmony scores across the musical and color domains. This adds support to Palm and Griscom's hypothesis that preference for harmony could represent an aesthetic tendency influencing our taste in music and visual art. Additionally, our finding that familiarity contributes to harmoniousness judgments provides evidence that preference for harmony may actually reflect a preference for more familiar stimuli instead of just a preference for stimuli that represents good gestalts. However, Study 1 had a potential limitation in that we used a corpus-based measure of chord familiarity. It's possible that people's subjective perception of a chord's familiarity better indicates its processing fluency, and subjective familiarity may be a stronger predictor of harmoniousness and preference for harmony. To test this, in Study 2, we removed the color stimuli and only presented participants with musical chords. We used the same set of 44 musical triads as in Study 1, but added a subjective familiarity rating block, asking participants to rate how common each chord was. Study 2 replicated the results of Study 1, except for the multiple regression analysis that used ad hoc individual difference measures to predict preference for harmony. In Study 1, we found that aversion to roughness was a significant predictor of preference for harmony. However, Study 2 showed that none of the individual difference measures was independently associated with preference for harmony. When we replaced objective familiarity with subjective familiarity, we found that subjective familiarity was a significant predictor of harmoniousness, with roughness showing a marginally reliable mean effect. We also found that preference for subjective familiarity was a significant predictor of preference for harmony. Our findings in Study 2 further supported our hypothesis that preference for harmony may actually be a preference for familiar stimuli instead of a preference for stimuli that are intrinsically harmonious. However, there may be other explanations. Subjective familiarity ratings were almost perfectly correlated with preference ratings. This suggests that people might have used a warm glow heuristic, essentially using the pleasantness of chords as an anchor to judge their familiarity with the chord. If this is the case, the subjective familiarity self-report may lack construct validity. At the same time, our ad hoc measure shows that roughness is a more robust predictor than objective familiarity. This also confirms the possibility that preference for harmony reflects a preference for harmonious stimuli and not just familiar stimuli. In Study 3, to address the limitation in Study 2, we introduced a mere exposure procedure as a more straightforward familiarity measure. The mere exposure effect illustrates how people tend to prefer things simply due to familiarity. We showed 3 different sets of stimuli to participants. The exposure frequency of each stimulus was manipulated, and participants were required to rate their preference for each stimulus. If a positive correlation exists between individual preference for harmony scores and strength of the mere exposure effect, it could suggest that preference for harmony, at least in part, reflects a preference for familiar stimuli and not just a preference for stimuli that are good gestalts. We computed a linear mixed effects model on the liking ratings of the stimuli. As you can see in the left graph, there is a linear trend of liking that increases with the exposure frequency, confirming that the mere exposure effect was successfully induced. From the random effect structure of the linear mixed effects model, we derived individual slopes to represent individual differences in the strength of the mere exposure effect. A higher positive value reflects a greater increase in liking ratings with increased exposure. As you can see in the right graph, there was individual level variability in the strength of the mere exposure effect. This individual variability allows us to measure individual differences in preference for familiarity. We further computed the correlation between individual differences in preference for harmony and the strength of the mere exposure effect. As you can see, there is a modest but reliable positive correlation. This suggests that preference for harmony is associated with individual preference for familiarity, regardless of its intrinsic structural goodness. Same as the first 2 studies, a multiple regression on preference for harmony scores was conducted with individual preference for harmonicity, preference for objective familiarity, and aversion to roughness as predictors. We found that aversion to roughness and preference for objective familiarity were both significant predictors. This suggests that both preference for good gestalts and familiar stimuli may contribute to individual differences in preference for harmony. To summarize, our research provides evidence that preference for harmony is an individual difference variable that predicts people's aesthetic preferences across the visual and musical domains. Our research also indicates that preference for harmony does not only represent a preference for structurally good gestalts, but also at least partially reflects a preference for familiar stimuli. As we've discussed before, both structural good gestalts and familiarity can enhance processing ease. The question arises, what drives people to prefer stimuli that are easier versus more difficult to process? One possibility is the difference in individuals' cognitive ability. Those with higher processing abilities might find simple stimuli boring. However, this theory hasn't been tested yet. Another possibility might be that preference for harmony does not stem directly from differences in processing ease. Instead, it's related to the metacognitive feeling of processing ease. People might vary in their awareness and dependence on these feelings when making preference judgments. Those with higher preference for harmony might prefer harmonious stimuli because they are more attentive and sensitive to the ease or difficulty in coding these stimuli. In conclusion, our findings challenge Palmer's idea that preference for harmony merely represents a preference for good gestalts. Instead, we propose that preference for harmony is significantly associated with at least 2 distinct measures of familiarity. This suggests that preference for harmony may actually reflect an individual's preference for stimuli that are easy to process, and there is a potential link between individual differences in sensitivity to processing needs and aesthetic preference judgments. This is all I have for today. Thank you for listening.